This is Geometry Similarity Part 1 Review. This goes along with Unit 5. Unit 5 has 2 tests. It is a big unit, so that's why it's broken up into 2 separate tests. So let's take a look at what we got here. It says, for the first one, it says, compare the 2 transformations shown below with respect to the distance and angle measurements. So what is the coordination rule for the transformation? So we're making a rule. So if this one's A, this one's A prime, that makes this one my pre-image, and this one's going to be my image. So I'm going here and ending up over here. So now the X value, it's going to go this way. So numbers are getting bigger, so I'm going to add 1, 2, 3, 4, 5, 6. So it's X plus 6. And now I'm going down, so that's the Y value. 1, 2, 3, 4. So X plus 6 and Y down 1, 2, 3, 4. Down 4, negative 4. But now I need to, since I wrote it in here already, but I need to actually check to make sure that this works for all of them. Because if it doesn't, then it's not a rigid transformation. Okay, so now let's take a look at B. 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. That one works. C. 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4. So they're all correct. So all of them line up. They're all X plus 6 and Y minus 4. Explain the lengths and sides and the measurements of the angles of the triangle A prime, B prime, C prime in part A. Compare with the original triangle ABC. So now, because this is a translation, so this translation here, so it has a, so the translation is going to be, now here's a vocabulary that we had first semester, which we'll bring up again. So translation is rigid. So what it means by rigid is it stays the same size and it stays the same shape. It's just moving location. So that means same size and shape. Okay, so now part C. What would the coordinates of A prime, B prime, C prime be if it was transformed this much right here? So I'm taking the original, and I'm going to, says that I am going to multiply the X times 2 and the Y times 2. So this is going to be a dilation. So I'm going to put the coordinates first. So A is located at negative 2, 3. B is located at negative 2, 1. And C is located at 3, 4, 5, negative 5, 1. Now I'm going to do a dilation, so my X value times 2 and my Y value times 2. So X times 2, so it's going to be negative 4. My Y times 2, and it's going to be a 6. This is going to be negative 4, comma, 2 is going to be negative 10, comma, 2. So that's all it is. So for number 2, it says the coordinates of triangle KLM are located here. So K is 2, 3, 1, 2, 1, 2, 3. L is negative 2, negative 1, negative 2, negative 1. And M is 5, 1, 5, 1. And this is M. Okay. So I'm going to trace over this. There we go. So now I have that. Now, and it says NPM are 3.5 and 2. So 3.5 and 2 1, 2. It's going to put me right here on this spot, and that I'm going to name that one N. Next one is going to be 1.50, 1.50 right here. I'm going to label that one P, and M is at 5, 1, still right here. So now I have another triangle within my bigger triangle. There we go. So that's what it should look like there. So calculate the slope of KL and NP. So for KL, I'm going to use the basic form for this one right here, which is, since I have a graph, I'm going to use the graph. It's rise over run. So rise over run. So reading it from left to right. So for KL, I'm going to write this one down. KL. So KL, rise, it's going to go up 1, 2, 3, 4. So it's up 4, and it's over 1, 2, 3, 4. My slope is 1 over 1. Now, for my other one, which is for PN, slope is going to be, now, I'm going to do my X value, so it's rise, actually Y values, I'm sorry, rise. 1, 2, so it's rising 2, so this is PN. It's up 2, and it's over. Now, if I start halfway, I'm going to count by halves. So it's going to be 1, 2. There we go, 2. I could use the slope formula for this, and it'll give me the exact same answer, but I have a graph now, so I'm going to use this now. So which is going to give me 1 over 1. So that's going to be important for later. Now calculate the distance of KL and NP. So distance formula is equal to, so I'm going to show you, it's delta x squared plus delta y squared. So delta means it's the change. That means it's going to be how far apart. So distance, so I'm going to start with LK. So distance, square root of LK, so it's going to be my change in x. So how far are they apart in the x direction? Let's see. 1, 2, 3, 4 squared plus my change in y direction is going to be 1, 2, 3, 4. So LK is going to be square root, that's 16 plus 16 is 32, square root of 32. Now my other one is going to be PN. Do the same thing. Now my change in my x direction is going to be 1, 2, 2 squared, plus change in y direction, 1, 2. So PN is going to be square root, so that's going to be 4 plus 4 is 8. There we go. So I have my two distances there. Using calculations from A and B is the NP, the mid segment. So now let's take a look at part A. So now for it to be the mid segment, they have to be parallel, and parallel lines have same slope. So you could say same slope. So same slope, that's part of it, that's half of it. And the other half is that this one right here, sorry, PN needs to be half of LK, but I have radicals here, so this has to be half of that. So I'm going to do my PN over LK. So in my calculator, my PN is going to be square root of 8 over square root of 32. Let's see, I have square root of 8 divided by square root of 32, and depending on your calculator, to turn it into a fraction, I get 1/2. So I have same slope, so that means that they're parallel. 1/2, so that means that it is the mid segment. It's got to be both of these things. So yes, mid segment. There we go. It says, for number 3, graph DE with D and E being there on the coordinate plane below. So D is -2, -4. -2, -4, that's D. E is 4, -4. 2, 3, 4, -4. Right here, so that's E. Okay, so that's my line segment, DE. There we go. And it says graph the DE using the origin as the center and scale factor 1.5 labeled D prime E prime. Now, scale factor 1.5 means I'm going to take both of these and multiply by 1.5. So, I'm going to pull out the handy dandy calculator because I know some people have some issues with this. So, I'm going to show you how to do it. So, it's -2. So, I'm going to say -2 times 1.5. It's going to give me right here. So D prime is going to give me at -3. -4 times 1.5, -6. E prime is going to be 4 times 1.5. That's going to give me 6. And -4 times 1.5, -6. There we go. So there's my points. So there's my new points of D prime, E prime. So let's put those on there. So -3, -6. That is going to be D prime. And E prime is -6. I'm sorry, 6, -6, which would be right here. E prime. Draw your line. There we go. Find the length of the dilated line segment D prime E prime. So I'm going to find the length of this. So I'm going to use my distance formula again. So for DE, I have how far in my x direction? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squared plus the y direction. There is no change in the y direction, so that's 0 squared. So that's going to give me 81, and the square root of 81 is 9. So my answer is 9 units. Now it says find the value of the ratio of the length of the dilated segment to the length of the original segment. So the dilated segment is going to be D prime E prime over DE. So like that. So now I need to find the distances. So now again on this one right here, my distance, I have to find that distance. So again, this is no change in the y direction, but there is a change in the x. So 1, 2, 3, 4, 5, 6. So to do that one, it'd be 6 squared plus 0 squared, which gives me 36. Square root of 36 is 6. So for this one, it's going to be 9 over 6. And I'm going to reduce that in my calculator. So 9 over 6, which gives me 1.5. Now, when I do this and I do this correctly, this answer right here needs to be my scale factor, which I have right here, which I started with. Okay. All right. So now, let's take a look at number 4. It says, which of the triangles, if any, is not similar to any of the others? Explain your answer. Okay, so now let's take a look. So this one right here is going to be side, side, side. There's no other side, side, side here. So this one is not going to work. This one is going to be side, angle, side. Let's see. This one right here, I have. Now, because I know that this is going to be side, angle, side, and I know that that is a right angle there, I could do the math. So, this isosceles, so it says that if the legs are the same, so are the shoes. So now those base angles have to be the same also. So let's see what that one's going to be. So I know that the whole thing has to add up to 180. So I would take 180 minus 90, because that's that piece right there. And because both these have to be the same, I'm going to divide by 2. Each one is 45. So now if I'm looking at it, this one right here, I have 90, 45, so that this one also has to be 45. Just because that's, if I do the math, 45 is what's going to complete this one. This one right here, I have 45, 45. And then if I do the math, it comes that this one is a right angle there. So now these are going to be similar. These going to be similar. So right here, so we have that B, C, and D are similar by side, side. I'm sorry. Angle, angle. What am I thinking? Angle, angle, similarity. There is no side, side similarity. All right, so B, C, and D are all similar by side, side similarity. Okay, so now let's take a look. Find the values of, let me make sure this is there. It says find the values of X and Y to measure, and the measure of angle P, which is shown here to show that these two triangles are already similar. So if they're already similar, then I'm in a good place. So I need to take a look. I have this one and this one. They're both the same. They're both in common right here. So now I'm going to have to use cross products to find one of the missing sides. So I could say 4 over 6 equals x over 9, because these two go together. I'm not going to use these because I don't want an x and a y in my equation. So it's going to be x over 9. Cross products, 36 is equal to 6x. Divided by 6, x is 6. Sorry, x is 6. So x is 6. Now we're going to do the same thing for y. So 4 over 6 is equal to 7 over y. Now the 7's on top because that's the 4 is also on top. So 4 and 7 are both on top. So that's why it gets set up like this. So it's going to be 4y is equal to 6 times 7 is 42. Divide by 4. Y is 10.5. Here, I can hear your skepticism right now. So, let's see. 6 times 7. 6 times 7 is 42. Yes. Divide that by 4. And I get 10.5 as my answer. So all you haters out there, I was right. So that's 10.5. So now I have that one set up. So now it also says for the measure of angle P. If these two triangles are similar, that means that S goes with P, T goes with Q, and V goes with R. So all these angles are congruent to each other. So if angle S is 86, angle P has to also be 86 degrees. Use the side lengths proportionally to determine if the triangles are similar. So if they're similar, they all have to have the same ratio. So we're going to go ahead and do all of the ratios. But since I'm not sure what side goes with which, so I'm going to start with the smallest one. So the smallest one over here is supposed to be the smallest one over here. So if they are similar, they would go together like that. So it would be, let's go 7.5 over 3. Let's reduce that one. So 7.5 divided by 3. And I'm going to turn that into fractions. So I have 5 over 2. Okay. So now I'm going to do, so that's that one. So now let's do the middle one, which is going to be 12.5 over the middle one here, which is 5. 5 divided by 5, and I'm going to convert it to a fraction so I could see it. It's 5 over 2. And my last one is going to be 20 over 8. Let's see what that one comes out to be. 20 over 8 and math. Right. And that one's also 5 over 2. Now, they all have the same ratio, so since they all have the same ratio, these are going to be similar by side, side, side. Because they go to their sides. Yeah. Anyway. Alright, let's take a look at number 7. Okay, so 7, we actually have to do some extra math to go along with this, just so you guys could see what goes where and why. So there's a shape that goes along with this. This is an X shape right here. That means that this piece has to be congruent to this piece right here. So since this has an angle in common with this one, and it has another angle, so 2 angles in this triangle are congruent to 2 angles in this triangle. These two are congruent because they're vertical angles. Okay, so that means that these have angle, angle, similar. Now, going along with this one here. So this one, whenever I have parallel lines, I'm going to have, okay, parallel lines, I'm going to have corresponding angles. So this one's going to be congruent to, this always works in parallel lines. This one's congruent to this one right here. Okay, so now I have the big triangle, which is here. And I have the little triangle, which is right here. So I have one of them here. So I have this angle and this angle are congruent, but they both share this angle right here. They both have that same angle in common. So that's going to be reflexive since they both share that angle. It's congruent to itself. So that's an angle, and there's another angle. So this is angle, angle, similarity. So now on part C, let's take a look at part C. I need to do some math here to figure out what my third angle is. So let's take a look. We know that all 3 angles in a triangle have to add up to 180. So let's see. So it'd be 180 minus 80 minus 62. That's going to be 38. So when I do the math, this one right here comes out to be 38 degrees. So now this one is congruent to this one is congruent to this one. So now because of that, this is also angle, angle, similarity. Alright, part D says, so I have to do the same thing again, so I need to try and figure out this one right here. So given this, I know that that's 90, the box is always 90. So I need to find, this missing side. I'm going to find this one here. So if this one right here is 47, this is going to be angle, angle, okay? Only if this one's 47. So let's see. So I know that this is 90, so it's 180 minus 90. So minus that one and subtract that one, so minus 45, and that's going to give me my missing angle, which is 45. These two are not congruent, and these are not similar, because those two have to be exactly the same. Since they're not, it can't be similar.